video, we are going to talk about the upstream crude oil processing and the control systems involved in it. First, I'll go to the introduction. In this introduction, I will explain a little bit about the overall crude oil processing. It is divided into three stages, which is the upstream, midstream, and downstream. But here we mainly focus on the upstream system, where you can see here in this process flow diagram. In the upstream system, the mixture of gas, oil, and water will enter through this production separator, which is also known as a three-phase separator that is called, and sometimes called free water lockout tank, which separates free water from bulk oil liquid. It also separates gas from the bulk liquid. That's why it's called the three-phase separator. And why do we need to remove this water? Because water will cause pollution and formation of hydrates in pipeline, which of course is something that we don't want inside this crude oil processing. So we need a good separation process, and we need to achieve this optimum separation. And to achieve this, we need a certain pressure, the pressure where it is around 17 bar. And in this pressure, we can achieve this optimum separation. But and we have to maintain inside this pressure. So in order to maintain this pressure, we need to monitor this condition inside the separator itself, because sometimes the pressure there will be fluctuation of pressure inside this separator. So in order to monitor, we need this control system. It should be included in the localized control system that is also necessary to maintain the safety and productivity of the plant. And the control system that we will discuss in this video is the distributed control system, also known as the DCS.
Now, let's talk about distributed control system. As industrial processes becoming larger and more complex and geographically distributed in scale, integrated processes control system becoming more suitable to be implemented. An overall crude oil processing plant usually stretch up to several hundred kilometers in total areas, making centralized control a challenge. Offshore extractor cannot bear the delay to receive command from the land-bounded control room before making their decisions. And onshore refineries will need to make decisions before the parameters causes errors. And so, distributed control system, short for DCS, becomes a major part of the system control in engineering industry. This case study we have been studying utilizes DCS control as part of their major control system. There are four important elements of DCS that differentiates this type of control system from other type of control system. The first part is the engineering PC, which centralizes the overall control system of the upstream crude oil processing. Underneath the PC are the major advantages of DCS, which are the human-machine interface, short for HMI, which provides system controls at a local level to provide instant output to the local process system. Following that is the distributed controller, which receives signals from the engineering PC and the human-machine interface to control the flow and parameters that are happening in the process. And last but not least, these elements are of course interconnected with a communication and media and protocol to provide communication among different levels of control. DCS is capable of handling complex processes that spreads out across a large amount of area. This is extremely important in the oil processing industry, owing to the large number of I/O devices, input and output devices. Apart from that, system redundancy is also the special feature it has, which increases the system reliability to prevent abnormalities from continuous operation. Aside from that, predefined function block simplifies the complexity of tedious coding and thus a simpler system. Apart from that, DCS has sophisticated human-machine interfaces as described before, HMI, that is capable of inputting the set point rather than the need to rely on the centralized PC to operate. In short, DCS simplifies the controlling system of a processing plant by distributing it on the local level.
Before starting with the challenge, we first need to know the components that can be found in wells, such as water, oil, sediment, and gas. But the components that we want to separate are gas, oil, and water. So, what happened for these components after the separator separate them? For gas, it will be sent to the gas plant, and the gas that which they don't want, it will be sent to the flare. For the water, after the free water knockout tank, then it goes to the skim tank, and that water can be used for the well injection. For the oil treatment, after the free water knockout tank, then to hydration tank, then the oil will be exported. There are three types of separators according to their shapes: spherical, vertical, and horizontal. The main shapes which are used, vertical and horizontal. According to their faces, they can also be separated to two-phase separators and three-phase separators, which we are going to talk about. Three-phase separators, which means that oil, liquid, and water. And as it can be seen here in this picture, in the controlling process, they're concerning about the level control valves for the oil and water, and also gas control valves. The challenge, there are basically two main challenges that separator process faces when separating crude oil that come from the upstream process, which are controlling the pressure of the gas, and other one is controlling the level of the liquid. But we'll just talk about the controlling the level of the liquid. The fluid which comes from the manifold, it then go to the separator from the inlet. Then after that, for some cases, it can suddenly increase the level of the liquid so fast and go beyond the limit. The liquid takes gas path and spoil the pipe with the gas which was collected previously.
Now I will talk about suggestion. There are several ways to modify a free water knockout tank for better yawn of the separated products. First is to connect a flow meter to the entrance of the tank. A sensor can be set up to detect changes and to further correct it to the set point. First of all, the natural gas is separated from the tank by adding a gas boot prior to the tank. This will allow easier separation of the different liquids in the tank. While in the tank, the controlling of the wire's length adjusts the height of the water to be maintained at the desirable level. This will ensure that all the three liquids discharge at the suitable exit. Besides of that modification, the tank achieves a better yawn of product by designing the tank in which a floating valve less dense than water but denser than oil. This will allow the floating valve element to float on the water and to open the check valve, and the sink in the oil is to close the check valve. All of this is to ensure the water level to be controlled and trigger a first drawn shut off valve to allow water to be discharged beneath.
we have 5 points to talk about. First of all, the upstream crude oil process depends on DCS system to support and control the whole system for continuous operation. 3 phases separator was used to separate the crude oil. The challenge was to control the level of oil and water in separator in their respective outlet stream. There are several modifications of FWKO tank can be implemented to control the water level so the products does not mix. Finally, suggestions help to produce a higher quality, efficiency and environmentally friendly product.